Alright, in this video, we'll be implementing this amazing project. It looks complex, but trust me, it is a mini project, and we'll be doing that with the help of Terraform. So if you are new here, hello, my name is Piyush, and this is day 24 in 30 days of AWS Terraform series, and we'll be implementing an end-to-end mini project for a web application hosting in AWS. We'll be making sure that this application is highly available and fault tolerant as per the best practices as per well-architected framework. This is a mini project. It will not have the database or the backend layer, so it will have front end, and then it will have auto scaling groups, and it will have few other infrastructure concepts which is really important to understand. And later on in one of those videos, when we understood all these concepts, how it works, then we'll be extending this project into a 3-tier architecture, which will be again fault tolerant and highly available. So without wasting any time, let's start with the video. I'm sure you have been supporting the channel. I'm sure you have been following along and implementing all the projects, all the videos by yourself, and I'm sure it will be a good learning experience. If so, let me know in the comment, and let me know if you are facing any issues. Okay, so let's try to understand this project, and then we'll be looking into the code and like all the other things as well. So as you can see, here is the user. This is the user which is accessing the web application. Okay, the request will be made over the public internet on port 80 or 443, HTTP or HTTPS, and then that internet gateway, the request will go to application load balancer. So we are exposing this application through an application load balancer provided by AWS. This application load balancer has two target groups. One is EC2 instance in private subnet A, and another one in EC2 instance private subnet B. Okay, so these two subnets are in different availability zones. So this will what make the app highly available, right? This is in different availability zones. So even if one entire zone goes down, even if this zone goes down, then the request will be forwarded to the secondary zone, which is over here. If this goes down, the request will be served through the primary zone, right? So it is highly available because we are spanning the app across multiple availability zones, and because it has an application load balancer in the front, application load balancer can span across multiple availability zones. Okay, and then we are making sure that this application is not directly exposed to public internet. We are exposing our application load balancer endpoint, but we are keeping the backend or like the application logic behind private subnet. So these instances will not be accessible over public instances. That is what making it more secure. So spanning the app across multiple availability zone is what it will make as fault tolerant, right? Because the application can withstand a availability zone failure, right? But what happens when the load on the server increases and it needs additional server to fulfill those requests? So that is where our auto scaling groups come into the picture. These instances are behind an auto scaling group. So we have set minimum, maximum, and desired number of instances over here. So minimum is 1. That means at a time, one instance will be running in both of the availability zone. Maximum, it can go up to 5 instances. And desired is 2. That means it will start with 2 instances when the server will provision. When we start it, it will start with 2 instances in each of the availability zone. The max, it can go to 5. Sorry, not in each of the availability zone. I mean, the total should be 2. And when the load is really low and below the threshold of whatever we have set, it can go up to minimum of 1 instances. That means 1 instance can be deleted. But it will be a good practice if we keep minimum and desired as 2. And then maximum can go up to 5. That means it can add additional 3 more instances. Okay. When it will do that based on certain metrics that we have set. I will walk you through that as well. So whenever, let's say, CPU utilization goes above 70%, then it will add additional server. When CPU utilization goes above 60%, it will have additional server, something like that, and few other metrics that we can use. Okay, so using the same app across multiple availability zone is what making it fault tolerant, And putting the EC2 instances behind an auto-scaling group is what making the app highly available, right? So application load balancer will forward the traffic to EC2 instances. Now, these EC2 instances, we are not directly hosting the application on these instances. What we have done is we have installed Docker on these machines, and the app is running as a Docker container. So there is this Django app, and what we are doing port mapping. So there is the host port 80 that is open, and then that port 80 is being mapped to the container port 8000, right? So it will do the port mapping, and the app will be running on container port 8000, but it will be available on port 80 because we have done the port mapping. The same for the other, because they are being built on the same instance template. So the same thing will be for the other server as well. Okay. So that's the inbound traffic, how user will access. So it will go from here to the internet gateway to application load balancer. Application load balancer forwards the traffic to either of the EC2 instances. If there is additional load on the server, the auto scaling group will add more servers. And if the entire availability zone goes down, the application will still be serving the traffic through the secondary availability zones, right? So that's the first part of it. Second part of it, now that we have the servers in private subnet, how it will pull the Docker images, right? Our Docker images are, let's say, residing in a Docker Hub registry over here, which is outside AWS network. Or let's say we are using a third-party Artifactory or Nexus, any other third-party Docker registry. How would we able to pull the images, or how would we able to patch these servers for security updates, for vulnerability fixes, and so on, right? So it needs the outbound internet access. But because these servers are in private subnet, that means it doesn't have the outbound internet access. So that is why we are using an amazing service which is called NAT Gateway. So we have placed one NAT gateway in each of the availability zone, because NAT gateway is zone specific, right? So we have to create NAT gateway in each of the availability zone in the public subnet. Okay. So there is this public subnet AZ1 and the public subnet AZ2, and both of them has the NAT gateway. So now when in this EC2 instance we'll try to pull the image, the outbound request will go to the NAT gateway and to the internet gateway, and through the internet gateway it will go to Docker Hub to pull the image, right? The same thing over here as well. The request will go to NAT gateway and to the internet gateway and then to the Docker Hub. So what will happen in this case, instead of EC2 instances going directly to the internet, actually no, it will not go to the internet gateway. It will go from NAT gateway to Docker Hub. Yes, okay, let me just verify this real quick. So if we go to AWS white papers, and the white paper was 3-tier architecture. Let's see. Not serverless, traditional web hosting. Okay. So if we look at this and let's go back, I'm not sure if in this they have used NAT gateway or not. Okay, so let's search for NAT gateway AWS, and yeah, let's look at this over here. So this is a Medium article, but I think this is good enough. So the request goes from EC2 to NAT gateway to the internet gateway. Oh yes, it goes to internet gateway. That means let's just verify it one more time on the official documentation. NAT gateway basics, they don't have a, yeah, over here. So if you can see, client NAT peering destination. Okay, but what I'm trying to look is how it accesses the internet, right? So private subnet, NAT gateway, and from NAT gateway to internet gateway, and then internet. Okay, yeah, so that's correct. So instead of going directly from public subnet to internet gateway, it is going from private subnet to NAT gateway, and then NAT gateway is routing the traffic to internet gateway, which is what we have done in our use case. Okay, so this is correct. So this is how it will pull the image, and this is how it will download the updates on the server as well. So that's the additional part. And yeah, I believe that is all. That is what we are going to do in this video. So let's go to our VS Code. Over here, I'm inside day 24, which is over here. Okay, day 24 code. Okay, now it will have, as you can see, let me just set the alias, and let me also change the terminal to make it readable. I'm inside day 24. Okay, so over here, what we have done is we have divided the resources into different Terraform files. So first is ALB, and then ASG main. Let's start with the main. In the main, it will only have the provider configuration. You can call it provider.tf or whatever you want to call, that's okay. So over here, we are using the same AWS provider that we have been using, 5.0 or 6.0. So in most of the videos, I have used 5.0, and some of the videos I have used 6.0. Both of them are working for me. And then we have also used the random provider to generate some random strings. Here are the provider details with some default tags and the default region. Now start with the ALB. Okay, so ALB is for the load balancer. Okay, and we are making sure that it is not an internal load balancer. It has to be the external load balancer. And load balancer type is application. So we have different load balancer in AWS. We have application, we have classic load balancer, network load balancer, and yeah, I believe we have 4 different type of load balancer in AWS. So what we need is an application load balancer. And security group is AWS security group, which we have created in a different file, ALBSG and ID. So for ALB, we have created a separate security group. Let's check this security group first. So AWS security group, ALB, and VPC ID, which is the VPC that we have created. And for this load balancer, we are enabling HTTP from internet on port 80 and HTTPS from internet on port 443, which is what is required. And egress is allow all outbound, and that is for ALB. For EC2, we are enabling port 80 access only from ALB. Right? We don't want to expose our EC2 instances publicly. That's why we are only enabling it from load balancer. So here we have provided security groups equal to AWS security group .albsg.id, which is this one. Okay. And same thing for port 443, only from the ALB security group. Now this is security group for SSH access. Let's say if you have some issues, you want to troubleshoot, you are admin, you should have the SSH access. So for that, you are providing SSH access to the EC2 instances. For now, I have kept it at 000, but make sure you change it to your IP or your CIDR for your organization, or if you are behind a VPN, your VPN CIDR, right? So it should be secure. And then this is an additional group that we have created. So you can ignore this if you want. And also this one is also, we have used the ALB security group, so ignore this one as well. Right, now let's go to VPC security group. So we have created a VPC with enabled DNS support and enabled DNS hostname. This is important, otherwise our apps would not be accessible outside the VPC. Right, and then CIDR block, we have used the variable for that. Now we have created multiple subnets, and these things, these functions and everything we have already explained multiple times. So what we are creating is a public subnet for NAT gateway, actually 2 public subnets, and that is why we have used count.index over here. We are doing it 2 times, for one for each of the subnet and one for each availability zone. That is why we have used count.index over here. So 2 subnet will be created with this resource, and 2 private subnets will be created with this resource. Now, how do we differentiate between the names? So if you have noticed in the tags, we are using count index +1. Okay, so the first will be created as public subnet -1, second one will be created as public subnet -2, similarly over here as well. Now, same thing, we are creating a public route table. Okay, and then we are creating routes. So this is the route for the internet gateway, and then we are associating it with the public subnet. Then we are creating an internet gateway over here, and now we are creating route table for the private subnet. Over here is the route for private subnet, and as you can see, destination is 000, but the NAT gateway is the target for that. And then we are associating it with the route table. I'm not going into the specific of route tables and networking, because I'm sure you would have watched the day 0 video in which I have explained there are some prerequisites for this series, and I have provided the video as well in which you understand all these VPC related concepts. So I'm just going on a high level. Otherwise this video will be 4 hours long. I don't want to do that. Okay. So then we are associating private subnet with that route table, and then we are creating one NAT gateway per availability zone. Again, we are doing that with count.index. So allocation ID, subnet ID, and the tag as well. Now this NAT gateway also need an elastic IP. So that is why we have created one elastic IP per NAT gateway instance. And the same way the name has been given in the incremental order, but this will be dependent on the internet gateway. Okay, so these are the main infrastructure resources, and we were looking into ALB as well. So application load balancer created, and after that the target group will be created. Target group which will redirect the traffic from the load balancer to the backend server. Backend servers are the EC2 instances, right? So over here we are saying HTTP protocol with VPC ID as this. The first target group will do the health check on path/, and then this is the interval, timeout, healthy threshold, unhealthy threshold. Healthy threshold meaning it will do the health check after every 30 seconds, and as soon as it get 2 successful replies consequently, then it will add the servers to the target group of load balancer. If it gets 2 unhealthy threshold back to back, then it will remove those servers. That means those servers are not healthy, and it will replace it with the new server. Okay, so that's the health check for the target group. Now there is a listener as well. So there is a target group, and then there is a listener. Listener is what is responsible for forwarding the traffic to the target group. Okay, target group is which is doing the health check on the servers, but then listener is responsible for forwarding that HTTP traffic to the target group. So we provide the default action target group ARN as the target. I mean, if you have HTTPS enabled, if you have installed SSL certificate, then you need to add HTTPS listener as well. And then you need to add the target group for HTTPS as well. Okay. So then we have auto scaling group. Now auto scaling group has a launch template, right? Because when a server is deleted, so let's say this server is deleted, new server will be replaced by this, right? Or when the load on the server increases, a new server will be provisioned. But then how would that new server know the instructions to install Docker or do the port mapping or to execute this Django app and the container mapping to it? How would it know like what it needs to be done? So all those instructions are there in the launch template. So that is why we need to create the launch template and associate that with the auto scaling group. Okay. So launch template will have an AMI ID, a default base image, and then we pass the instance type. We provide the security group IDs to be associated with it, and then there'll be a user data script. So this is the user data script which will have the instructions to install Docker, pull the Docker image and run the container, right? So it's there in this script folder, and then some metadata, tags, and so on, right? So that was the launch template. Once the launch template is created, then we create the auto scaling group. Auto scaling group will have the details like minimum size, maximum size, desired capacity, and VPC zone identifier. Okay, so over here we are providing the subnet ID of the private ID. So private star, if you remember from the video day 10, I believe we have discussed splat expressions, right? So this is what we are using over here. This is the splat expression. Then target group ARN, like the target group that we have created for load balancer. Health check type is ELB, which is elastic load balancer health check, and this is the grace period and the launch template that we are using for this auto scaling group. So launch template that we have just created, okay, and then the tags. Then we need to create the auto scaling policy, because how would it know how to scale up or how to scale down, right? So actually there is a concept of scale up, scale down, and scale in and scale out, right? So scale up, scale down is usually referred in when we are upgrading the server to a bigger server, right? But when we are adding additional server, then we call it scale out. Okay, so there is a difference between horizontal scaling and vertical scaling. Okay, so over here we are creating the scale out policy. What we are saying, scaling adjustment 1 cooldown period is 300, and then similarly we have the scale in policy which says cooldown period is 300 second, and now we need to provide the metrics based on what it will track the scale in and scale out, right? So over here we are saying that where policy type is target tracking scaling, and here's the target predefined matrix ASG average CPU utilization is 70. So there is a matrix for ASG average CPU utilization. Whenever this matrix is above 70%, then it will do the scale in. Okay, so that's what we are saying over here. And then we are also setting the CloudWatch alarm. So whenever there is high CPU, meaning there is a different matrix over here which says threshold is 80, average period. So that means over a period of 120 seconds, over a period of 2 minutes, when the average CPU utilization is above 80%, then it will kick off the CloudWatch alarm. And then this is the alarm for low CPU as well. So when it goes below 20%, that means it might delete the server. So that is what we are doing over here. Okay. And basically that's it. You can check the variables over here. So we have variables for region, environment, VPC CIDR, public subnets, which is a list of string, private subnet, which is also a list of string, and then public subnet count is 2, private subnet count is 2, availability zones are these two. This is the AMI ID, instance type is T2 micro, desired maximum, minimum, and S3 bucket is optional. Like we have used it for additional storage if we need it, but we won't be using that in this project. Okay. So now that we have seen everything, it's time to run tf init, tf plan, and tf apply. So let's do, and let's see if we get any error. We'll fix that on the fly. So tf plan, okay, it says 42 resources will be created. So we did not see any error. Now let's run Terraform apply auto approve. Okay. So because it needs to create auto scaling groups and servers inside it, run some user script, install Docker, and a lot of things. So it might take some time. I'm gonna pause the recording till then, and then we'll come back and see the servers. Okay, it says the resources have been provisioned. So let's go and check the load balancer URL first, which is over here. And let's check this out. Oops, bad gateway. So it might be coming up. So let's go and check the resources. What I need is load balancer, which is over here. And here is my load balancer, which says it is active. And let's check the listener. So it says we have a listener rule which is forwarding the traffic to app target group. And if we see the resource map, so this is how it works. So resource, the instances are not healthy yet because it is still doing those health checks, right? So the listener is running on port HTTP port 80. There is one rule which forwards the traffic to the target group to the instance. And there are two targets. Both of them are unhealthy at the moment. Health check is failed. So we need to wait for the health check to be fulfilled, and will make sure that the servers are healthy. So let's go to EC2 and let's log into one of those servers. So this is the app instance 1 and 2, and let's go inside one of these servers, connect, and I'm just okay. It's not giving me the connect option because it doesn't have public IP. Maybe that's why. Yeah, no public IP address assigned. So that's another lesson for me. We need to attach the public IP to the EC2 instance to be able to log into that. So let's just wait for some time for the server to become healthy, or else we'll add the public IP, and for that the servers has to be recreated and then it will reattach to the auto scaling group. But I think if this is what we have to do, so yeah, we'll do that for the troubleshooting. Otherwise we wouldn't know what the issue is if there is any issue. So let's go again to the target group, which is this one, and it says too unhealthy. Let's see if it shows any errors over here. Health checks, these are the health checks, and if we do the monitoring, it says 2 unhealthy hosts. And let's go to targets. Yeah, it won't show the error over here. Okay, so it is draining the other one because after some time, when it couldn't find it healthy for some time, then it will drain it and try to add the instance again. So yeah, I think let's do that. Let's try to make those instances public and we'll see if there are any issues or not. Okay, so let's go back to our code and let's see where the changes needs to be done. So if we go to auto scaling group, okay, inside launch template, I believe that has to be done. Okay, so let's see the resource AWS launch template over here, and let's see. I'm gonna just search for public associate public IP address equal to true. So we just need to add this tag network interfaces inside the launch template. Okay, and here it is. So I'm just gonna add it over here, and then let's run the apply again. Wait, those instances are not public, right? Yeah, so we should not be adding it because we have kept that in a private subnet for a reason. Sorry, my bad. Let me remove it. So why it's not letting us do the SSH login? It's not letting us do from there, but we should be able to do it from the backend. Okay. So let me just check this one more time if it is still unhealthy. Yeah, it tried to add a new instance, but that is also unhealthy. Okay, and if I do connect, it says, okay, let's try to see if it is letting me connect through the private IP. Okay, now we need to select an endpoint. We don't have an EC2 instance connect endpoint to connect, so let's try to create this endpoint and choose a subnet on which this endpoint will reside. So let's choose public subnet 1 security group. It says allow SSH, create endpoint. Okay, and it says creation in progress, so I'm just gonna let it create. If it doesn't work, we'll figure out something else, but let's try to see. Okay, I think the app is active now. We don't even have to log in. So let's try to check. Load balancer, and inside load balancer, listener and rules, or maybe resource map. So it says one server is healthy now. So it took some time, and then one server is healthy and one is still failing the health check. So it might come up soon. So we need to just wait for that, and we can just actively monitor from the target groups over here. Target groups and then targets. Okay, over here it is not, yeah, it is showing as healthy, and these are all draining. So this 1A has been replaced by a healthy instance over here, and this will be done shortly as well. So yeah, so there is this new instance that has been added, and it is doing target registration in progress, and we need to just wait for some time for this to happen. It's currently at the initial health check. It is doing the initial health check, so let's just wait for that. Okay, it is unhealthy, but ideally, because both the instances are being created from the same instance template, so either both should work or none of those should work, right? So let's go ahead over here. The instance is running, but still it is failing the health checks. Maybe the user data script did not run properly on that or something else. But there is, I believe, no point of logging into that, because even if I log in, by the time I log in, that instance will be deleted and replaced by a newer one, right? So let's go ahead over here, target and see. Yeah, let's try to do that. Okay, instance connect using a private IP, still creation in progress. Okay, maybe it's gonna take some time. Okay, by the way, our app is active and we have seen the live example of high availability and fault tolerant, right? So our app is running. This is a Django app, a static application that we have. Even though one of the server is down, one availability zone is not working, our application is still being served from the other availability zone. So if we keep hitting refresh, the app is still running, right? Let's see if this is working. Okay, it might take some time. The other thing you can do is put some load on the application and see if it is able to create more servers or not, right? But before that, we need to connect to the instance, which is somehow it is taking some time. Okay, so let's try to load balancers, and let's go to target group. Okay, now both the instances are healthy. Okay, so let's not log in. Maybe you can figure out the login, but it's highly unlikely that either of the instance is not working, because it's the underlying instance template. It's same. We have used the same instance group. We have used the same security group rules. Everything is same for both the servers. So either both will not work or both will work, right? So it was just taking time to register the target to do the health check, and that is it. Now both the servers are healthy, and now the next part is you can try to push some load on the server and see if it is able to add additional servers or not. So there are multiple ways. One way is this is what I have shown you earlier as well, using an app called Apache JMeter. Where is my terminal? Okay, yeah, so I can just run JMeter and I can launch multiple threads on this application. Add a thread group, and then inside the thread group I just have to Number of threads, let's say 1000 threads, and I need to pass a file as well. Why it is not showing that? Maybe if I want to save your plan first. No. So I think I need to add this, or let's open a file, and it was there in user 𝗵𝗠 downloads. Okay, here it is. Nope, not this. Wait, let's just remove this. Okay, and let's open a new file now. Open. Okay, now it's open. Now we need to provide number of threads. Let's say 1000 threads. And if you go to HTTP request, you just need to provide your server IP over here, server name or IP. So I'll just put my load balancer DNS, which I can get from here, upload balancer, and there'll be DNS name over here. Scope pack, let's provide the DNS name, and port number is 80. Protocol is HTTP, path is /, that's good, and let's hit start. Okay, now if you can see the result, it has spawned 1000 concurrent threads to this server, to the load balancer. And let's go ahead and see the health of the load balancer. So go to monitoring, and we see there are a huge number of requests being piled up. So lots of requests are coming, and it takes some time for the requests to be shown over here, but you will see something in ASG group. So let's go to EC2 server, and then look for ASG, application secure auto scaling group over here, and let's see, we need to check if it increased the CPU utilization or not. Okay, so here are our scale in and scale out policies that we have created. CPU greater than 80 for 2 consecutive periods for 120 seconds, then it will add new server, and less than 20 it will delete the server. Now, okay, so we need to check if there are load on the server or not. So let's go to each of these instances. Okay, one server, okay, no, both are running. So let's go to this instance and go to monitoring. Okay, and CPU utilization is not that bad still, so that's why I did not add more servers. Okay, it peaked to 55% and then it went down, maybe because it started the thread and then it somehow the request has been blocked. It's getting failed now. We're getting 502, but if we check the app from here, okay, so the app is overloaded, looks like it, but it did not increase the CPU for that. Let's see, let's hit refresh. Okay, and says CPU and status and alarm. Okay, no alarm. Somehow maybe AWS detected it as a brute force attack and blocked the requests, and now I'm not able to access the application. Yeah, So what you can do is let's just stop this. Okay, it's getting the response code back again. I think the application is back now. So what it did, let's check if it did anything or not, or it was just a temporary block. Let's go to resource map and target group. Okay, it drained both the, okay, now it is healthy. One instance came back up, but it did not add more instances. So maybe it overloaded the server, but it did not actually overload it based on the CPU. It did not increase the CPU so that it could add additional server. So it overloaded the server, maybe memory utilization, or maybe the network bandwidth. It occupied everything, and then it forced it to recreate the server rather than adding additional server, right? So this test would not work in this case. Okay, so I'm just gonna stop this. Okay, shut down all the threads, please. Okay, it's gone down to 0. So let me just remove this. It will add the server back. Now what you can do is you can test this by running curl on this load balancer UR multiple times, or just keep hitting refresh, and maybe reduce the auto scaling group from 80 to, let's say, 10%, something like that, so that you should be able to test it quickly, right? I don't think manually it will be able to put that much of load on the CPU, but you can try it out using a for loop inside the curl and put the load on the server, or you can run any sort of stress test application. Okay, yeah, it is still trying to add the additional server. It has not, but it's gonna take some time, so I don't want to waste more time on that. The actual demo we have already seen, so maybe this is on you to test this out, test how to implement, how do we test out the high availability, how do we put more load on the server so that it could add additional servers, okay, to increase the CPU utilization. For now, make sure, if you have completed everything, make sure you do the cleanup, otherwise it will cost a lot. Okay, so tf destroy -- auto approve. Load balancer is a costly resource, so even if you have a minimum number of servers running, load balancer could cost you a lot of money. So make sure you destroy the resources once you are done. And yeah, basically that's it from this demo. I hope you found it helpful. I hope you had a good learning experience. Make sure you implement the project by yourself end to end. Go to the task.md of this repository as always and try to implement the project. Okay, so thank you so much for watching. Have a good day, and I will see you tomorrow with the next day 25 video. Happy learning.